everything that we've done so far is to prepare you, to prime you for this getting into object role modeling. Hopefully you will appreciate some of the things that we're going to say. We're going to point up a lot more problems, but now it should be clear to you the nature of those problems and what we need to do to be able to fix those problems. Problems with any record-based or clustered-based modeling scheme. Then we'll look at ORM data modeling, the tool that we have, something a little bit about object role modeling. And then, and I don't know if we'll get this far, but then we want to talk about the fundamental constructs of object role modeling. They're similar, but we look at them in a little different way than we have so far. Okay. You remember at the beginning I gave you this pedagogical roadmap, if you like. We are now at the end of this path. We're now at number 7. We've gone through 1, 2, 3, 4, 5, 6, and now we want to look at ORM, or conceptual modeling as we call it. What are the modeling constructs that we look for? We've been dealing with entities, relationships, and attributes. But the notion of attributes has been messing us up, getting us into trouble, because attributes only arises in the clustering process. What's the difference between entities and attributes? Are they not both populations of something? Well, they are. Okay? We think of an entity as a domain of things. But how do we represent those things? We represent them by identifiers. And what's the identifier? It's a value. And if we look at a domain of values, we think of an attribute as being a domain of values. What does each one of those values represent? Well, it represents a thing. So here, the perspective on entities is we got a population of things, and on attributes, a population of values, but those are values of things again. Let me consider this distinction between the things in the world that we're trying to model and the strings or the values that we use to refer to them. Okay? This example of the day of the week. Are those all the same thing? They are. That all is represented by Tuesday. Now, you know, it could be written as Tuesday, or just Tues, or two, or mardi, or Marte. I don't know what. You tell me, how does this? Okay. You can pick. That's French and Spanish, as far as I know. But what's really important here is that when you pick an identifier or a set of identifiers, a set of values, those are always representing something, and our modeling is done in terms of those somethings. And we shouldn't get all hung up in the notion of the identifier. That's secondary to modeling the things themselves. Okay? So, we've got this real-world population of things. We find some lexical surrogate to represent them so that we can write down and have something that we can store in our database. And then that lexical surrogate is the set of values, or the domain of values, that can be used to populate columns in a table. Okay? Hopefully, there is a one-to-one mutually dependent relationship between the population of things and the values that we were going to use to identify those things. And we said that when picking an identifier. Everything in that population ought to have one. And it shouldn't change, etc. Notice we've got two populations that we're working with. The population of the things and the population of the representation of those things. They're identifiers. And the same can be said for other columns too. Is it any different? You know, you gave me some information in H1 about X. And then you came along and told me about A, and I said, tell me what it tells you about A alone. And you started telling me things like optionality and, you know, and single valued and all that kind of stuff. But those are characteristics of the relationship. What it says about A or B is no less, no more than what it says about X. There exists a population of things we're going to represent by values in the database. And furthermore, two columns could come from the same domain of values. If I had one was a birth date and another one was the date hired, those would come from the same domain of dates. And I could even apply some meaningful constraints to this, such as the date hired should be later than the birth date. Sounds kind of obvious, but if you tell the system that rule, there's at least something that it can do to raise the level of quality of the data, and that's what we're striving for. Okay, I showed you this before when we were reviewing H1. An attribute. I say, what is an attribute? An attribute is an object playing a role in a relationship with some other object. Could be the same type of object. What comes first? We have objects first. And then we have relationships. And then depending upon the nature of those relationships, we can start to talk about attributes. But only at that point can we start to talk about attributes. When we throw attributes into tables, we often don't think to ask these kinds of questions. What is the population that's represented? Could there be members of that population that would not be related to a member of this population? Are there other entities that have this thing as have the same attribute? Is there anything else of interest about that? These are the kind of questions you want to ask the users. Is it really an entity in its own right? Should it have its own table? Okay. All of those questions are questions that don't need to be answered. Well, no, I guess I better not say that. Anyway, we make assumptions implicitly about these questions when we go directly to designing tables. When we say attribute, nothing is an attribute by itself. Okay? When we say things like optional, required, conditional, single valued, foreign key, all of those are about the relationship between X and A, or A and something. Okay? If we just want to talk about A, we can talk about the lexical surrogate to identify them. We can talk about the names, the data type, the format, the size, precision, the set of values, and so on. And all of those would be talking about A by itself. How do we represent relationships? Well, there's relationships inside of a record when we cluster them. Unfortunately, with all of the clustering schemes, it's never explicitly defined. It's presumed. And since you're not telling the system about those intra-record relationships, the system doesn't know whether you did it right or not. Each one of those is a functional dependency. And if you tell the system about all of the functional dependencies, it can figure out that that's what to do, to put them together that way. Okay? So you've got relationships within records. You have relationships between records. That is, between the entities that are the identifier is used to represent. Okay? So we got within a record, entity with its attributes. Between records, that's between entities. Okay? Where are the foreign keys? Well, we'd have to add those. But if there's this relationship between X and Y, then we need to put the X as a foreign key in Y. Because in the relational world, that's the only way to represent a relationship, right? Okay. Are there any relationships between or among the attributes? In X, for example? I hope by now you know that there cannot be and there must not be. There are no relationships among A, B, and C. Because if there are, they're either not represented here or you're violating one of the normal forms. Okay? But just the mere fact of putting them together suggests that there's a relationship. Okay? And the majority of you said in H1, there is a relationship. Or at least you said something like, for example, there could be many A's for each B and there could be many B's for each A. But that's not meaningful and that's not a relationship. If that were true, then you're implicitly assuming that there is a relationship that I can talk about. But that's not the case. What if A has some other attributes? There's something else of interest about A. What are you going to have to do?
New entity.
Well, the entity A still exists. So you're not creating a new entity. What do you have to create, though? No, not yet. Not a foreign key. When do you ever have an intersection entity? When there's a many-to-many relationship. Only. What if A has some other attributes? H2, what do you do if you got some A's that have some other attributes? Where are you going to put those attributes? This ought to be right in the tip of your tongue. Where are you going to put the attributes of A? The other things that are of interest about A. Yeah, you create a new table for A. How many of you had that in your mind, but you just didn't want to say it? Sure. I would expect by now most of you would have. If there's stuff of interest about something, then those things are functionally dependent upon A, and therefore A has to have its own table. Yeah, do you want to pass the mic up?
Could you just take a second to go over the difference between an entity and a table? Because I guess I've been considering them somewhat synonymous, and apparently that's not correct.
That's a good question. Is X an entity? In this top of this diagram. X is an entity. Is A an entity?
If it has attributes under it that aren't related to X, or that are just dependent on it, I thought you'd have to break it out and make a new entity for A.
Okay, but if we have nothing else that's of interest to us about A, is A still an entity?
If A has an attribute, does that mean it's of interest?
The A's are of interest, but there's nothing else about A that's of interest. That's what the user is going to tell you. And A has a relationship with X. So, entity, I don't like to use the word entity. I like to use the word entity table. Because the table is used to represent something. Well, it represents the thing X plus only those attributes that have a functional dependency with X. That's what I'm doing here. I don't know if that helps or not. It doesn't help. Well, the table is the representation for an entity. Remember, the entities are those things out there. Okay? Persons, days of the week, whatever it is that's of interest to you. And every entity is a population. There's a population of them.
All right, so one more try, I guess. So we originally had A as just an attribute, and now we learned that A has more information about it, some other attribute under that that we want to record.
Okay, why did we put A in the table with X?
Because it has a relationship with X.
Precisely. It has a relationship with X. Okay? If it didn't, you wouldn't put it in there. If it does, you can put it in there. All right? Could I build a table of A's and put X in it?
I'm not sure.
It wouldn't be relational because there can be multiple X's for an A. But X is no less an attribute of A than A is an attribute of X, as per H1. Okay? It's by putting down X, we are simply setting our pivot point, nailing our foot to the floor, and we're going to say, okay, what else it relates to that? Well, A, B, and C do. And they better be functional dependencies or they don't belong together. And because you're not telling the system the nature of those relationships, it doesn't know. You're the only one who can know. Distinguish between what's being stored in a table and the things in that world that we're trying to model. Okay? All that this says is there's a relationship between X and A, X and B, and X and C. And by virtue of putting them in a table and presuming that it's a flat, then we are presuming that it satisfies the rules of normalization. If X has some other attributes, we need a separate table. If there are some orphaned X's, in other words, orphaned A's rather, if there are some A's that don't belong to an X, what do we have to do? We have to create another table for A. Now this is a table with one column. Is that an entity? Is it a legitimate table? Yes, of course. And it's only got one column. Because you have now elevated it. It's no longer just an attribute to X, but it's a thing in and of itself. But guess what? When we stored it with X, it was also a thing in and of itself as well. You see how putting stuff into tables really frames our thinking. And that's what gets us into trouble. I call it table think. What if A is still dependent upon X? Could I have A with a bunch of attributes and still have A dependent upon X? Is it functionally dependent upon X? Yeah. Except that it's not really dependent. Only those that are in with X are dependent. So you have to be careful. Functional dependency is a notion that only applies to individual records, never across records. But if I had A in two different places, one with X, I'd say, oh, there's a functional dependency between A and X. But if I could have some orphan A's, it's no longer dependent upon X. It's still a function.
Just to clarify that, so are attributes and dependencies irrelevant of each other? Like, does a dependency necessarily need to exist in order for them to be attributes of each other? Well, I guess it would technically, but does it need to be both ways? Because like A is dependent on X, right? But X is not necessarily dependent on A.
We usually say A is optional. And if A doesn't exist anywhere else in our entire database, then we can say A is dependent upon X. Because in our design, that's the only place that we're storing it. So it better be. But as soon as A can exist other places in our model, then it's no longer dependent upon X. Unless, and if it is for real, then you define it that way. You define it to be dependent upon X, even if it's not stored, well, you still define it as dependent upon X.
And in order for something to be an attribute of something else, does there need to be a dependency?
No. There doesn't need to be. That's why the whole notion of functional dependency in itself is getting us into trouble. Keep in mind, the whole notion of the rules of normalization only apply one record at a time. And you have to ignore what else is in your model. Because as soon as you look at things in other places, then in this particular example we're talking about, the dependency may no longer be true. And you'll see that this is explicitly dealt with in ORM. So we don't get into these kinds of problems. Okay, one more here. If we had orphans of or extra attributes of A, we would have to set up another table of A to store them. Now, if A was truly dependent upon X, even if we have this table, we just put the mandatory dot on A and say every A has to belong to an X. Okay, if I have a relationship, a binary relationship between X and A, this is how I represent it, right? I just put X and A together. Do I know anything else about that? All I know is that there's a relationship. Do I know anything about the nature of that relationship? I do not. Yet. A relationship is defined at the type level. If I say XA, there's a relationship, then I put X and A together in a table. And there's a population of X's, there's a population of A's, and the relationship is formed by picking an X and finding an A that it's connected to, picking another X and finding an A that it's, and picking an A and finding the X that it, now I can pick them either way. Doesn't matter. So at the instance level, all the valid XA pairs in my universe represents that relationship. Notice there's a relationship type and there's a relationship instances. Just as there is with a population of things. I write X, there's a string of values associated with the X. X is a population. Okay? So the relationship is all valid pairs that occur in the user's world. What's the identifier? You know, this is a little two-column table, right? What's the identifier? You have no idea. Why don't you have any idea? Because I haven't told you the nature of the relationship between X and A. If I told you that there could be multiple A's for an X, but only one X for each A, what would the identifier be? It would be A. What if I told you that there's a many-to-many relationship between X and A? This still represents that relationship, right? All I've done is I've added a characteristic to it. So if X and A was many-to-many, what could you tell me is the identifier? The composite key. Both of them together are required for the identifier. Remember the rule, if you got a composite key, there has to be a many-to-many relationship, and if you have a many-to-many relationship, there has to be a composite key. That's how we represent many-to-many relationships. Notwithstanding that in the relational model you can't do that. You have to break it out and have an intersection entity. And what's the identifier of the intersection entity? Funny thing about that, it's a composite key. So there's 4 choices, right? When I ask the question, what is the identifier? But I have to have said to the system what the nature of the relationship is before I can determine the identifier. You must know the multiplicity exclusivity characteristic of XA before you can put X and A in a table diagram. That requires the definition of an identifier, and a foreign key requires the prior designation of an identifier, and the foreign key would be a connection to some other thing. So if there was a table of A's around and you had X was the identifier here, then A could be considered a foreign key to that other table of A. So, when is a thing an entity and when is it an attribute? Common question. And there was a time when we used the phrase attribute migration. A thing's an attribute and all of a sudden it becomes an entity. And all we've done is we've built a table for it. Well, we saw we need an extra table of A, in this example, if there's some orphans of A or there's something else of interest about A. Suddenly A becomes an entity. Has anything changed about A? No. So is skill code an attribute here? Looking at that picture, you would say it was. Now add a description for each skilled code. We do this all the time in our databases. Okay? Now what is skill code? It sure looks like an entity, doesn't it? Because it's got its own table.
What would be considered not an entity?
A which?
What would be something that's not an entity?
Nothing. Everything's an entity.
Okay, so that's all right.
There are things.
Every object is.
Yeah.
All right, so could you do me a favor and just go back to slide 7, and I want to see if I can re-ask it just to try and get it right now.
There is a faster way to do this. Is that the one?
Oh, nope, sorry, I meant 8.
All right, I'll go directly to it.
So for the first dot, you had A has some other attribute, and then how would you show that? And then you said it was not by creating an entity. So if that question actually would have been A has some other attribute of interest, would it then have been create another entity?
No, it would be creating a table for that entity.
Oh, it's create a table for that entity.
You know, there's a subtle difference in those words.
Yeah, okay, I see that now. Thank
Okay.
you.
Come on. You don't. Listen, if you've got a thought in your mind or a confusion in your mind, there's probably somebody else in this room who does. Should we test that hypothesis?
Sure. About the filled in circle above A,
Yeah.
when you create the new table, is there any circumstance in which you change that?
Yes. If A can be an orphan from X.
Okay. So
And
then it's
it
no
may or may
long-
not be.
Then it would no longer be functionally dependent on X.
If you're going to look, that's true, if you're going to look across 2 different, quote, tables. And the notion of functional dependency only applies to one table at a time. It's still a function because there's only one A for each X. Okay? If, and think about it, here's how you might think about this. If A needs another table for A, because you've either got orphans or you've got other things of interest about A, if it still is dependent upon X, then when you pull A down, pull the dot with you. Okay? Because the A that's in X is the same as the population of A's in A. So the arc, you can see there's some redundancy here. Okay? This arc up here between A and X is exactly the same as this arc down here. And within X, A is still dependent upon X, because every A has to have an X. But if you've got some A's down here that aren't, this is the true nature of the relationship. And that's what you should be modeling. And you only get into this trouble because you wanted to put A in a table with X. Okay, we've represented. Okay, we're partway through here. So, now what's skill code? Some people would say, oh, it was an attribute of employee, now it's an entity in its own right. No. All you've agreed is that there can be some orphans of it, or there's something else of interest in this case description. So what's the relationship? Okay. The relationship, there's a relationship between what and what? Is it a relationship between skill code in employee and skill code in skill? No. The relationship is between employee and skill code. Okay? And that would be, what's the skill code in the employee table? It's a foreign key, right? It's almost to the point where when I ask you a question here, if you say foreign key, you probably got a 25% chance you're going to be right. It's like the Perkins that we used to go to up on County Road B. There were 5 Ashleys that worked there. So I could walk in the front and say, hi, Ashley, and I'd be about 50% of the time right. Anyway, we don't guess, though, do we? Okay? So, suppose an employee has multiple skills, not just one. Now you got to do something different, right? You got to take it out of the employee table. Why? Because now what is the relationship between employee and skill? You better say many to many. Don't tell me it's one to many, as many of you did on the quiz. Suppose an employee has multiple skills. If an employee has multiple skills, and a skill still has multiple employees, then it's a many-to-many relationship, and I have to have a composite key. What am I going to call that relationship? Or what am I going to call that table now? It's not really a table. It's a relationship. What are the relationships now between employee, skill code, and this new table? Well, employee is a foreign key up to employee in that table, and skill code is also a foreign key. Okay? Is skill code still an attribute of employee? Is there still a connection between employee and skill code? Yes. It just happens to be many to many, and because it's many to many, and because we're doing this in a relational model, I can't store them there, because it has to be single valued. You see the artificiality that's being introduced and imposed? And then there are data modelers out there that think this is the diagram that ought to be shown to the users to validate the picture of their world. How would you get, if this were all that were in your database, how would you get a population of, get at the population of A? What would your query look like?
select A from table X? Or
You
from-
got to do something more than that. I just want to see a list of all the A's. If I'm interested in the population of A, am I interested in duplicates? No. If I just said select A from this table, I'm going to get a list of all the A's, including all the duplicates, because it's just going to go down the column and give me every one. So what do I have to say? I have to say select distinct A. Then I'll get all the unique A's. That's how I get the population of A. At least it's all in one place, right? If that's all I have, then I know all the A's that I have are in X, because there can't be any orphans. Okay? Now, if A can be an attribute of both X and Y, is A still dependent upon X? The answer is no. Because I could have some A's with the Y that aren't within X, unless I define dependency between those two. Okay? And notice I can't do that here. So already we've got some limitations in how we can express constraints, dependency constraints, across tables. So how do I get the population of A? You're all SQL knowledgeable, right? You're going to have to do the union, but you're going to have to union what two things?
From X and Y.
Yeah, from X and Y, but what else do you have to do?
Distinct.
Distinct. You want all the distinct A's from X, all the distinct A's from Y, and take the union, and in the union you also have to throw out all the duplicates. Then you'll have the population of A. Do you think users ever would really like to see the complete population of A? Sure. But it ain't here. Now let's suppose A has its own table, because it's got some additional attributes. Now how do we get the population of A? Could I have some A's in Y that aren't in A? That's an interesting question, isn't it? What if there's an A that doesn't have any PQ, it's just the A by itself, and it's stored with X or Y? Do I need to create it in the table of A? Interesting question. And I don't really have an answer to that as far as this structure goes. You would normally want to think that all the A's are in A. And those that are associated with the Y are there, and those that are associated with X's are there, and there could be some that are orphans from either or both of X and Y. Did I see another question? Pass the mic over.
So when you look at that table, you think almost, well, it might be the same domain of A, all of them. They're almost just distinct and repetitive. They have no relation to each other.
The A's?
Yeah, because there's no relationships drawn between them.
Oh, okay. No, you're right. And can I, in a relational model, I have to have foreign keys to represent relationships. In general, arcs are quite sufficient for the user to represent relationships. And I haven't shown any arcs here. Okay? We know that there's a relationship between X and A because I put them together in a table. And that relationship is no different than from the X box to the A box. That's exactly the same. And A is only functioning as a foreign key here. Now, you get that? Okay. So I basically have to look. If I'm confident that there's no A's sitting in X and Y, then I could say all the A's are in the table of A. But I can't be confident in that because the system won't enforce that. So I could, in fact, have, just consider A is a date. And I've got dates of whatever it is, birth date, let's say. And and then in A, it was a list of dates that were only Fridays. Could I do that? Because it's only Fridays when I'm interested in P and Q, the P and Q of the A. The population of A and PQ can be different than the population with X and with Y in general. Okay? If you want it to be different than that, then you're going to have to define some constraints. Question? Yeah, grab the mic.
So in this case, we're not concerned about referential integrity?
No. If there is nothing in here that says you have referential integrity, that is a constraint that gets defined by the users. If you want to say every A that's in Y must be in APQ, okay, then you define it as such, and that's a constraint on the system. But in general, that would not be the case. That's why I said you got to separate the relationship from the enforcement of the integrity of the relationship. And see, if you did that, then what you're telling me is that all the A's that you've got in your system have to be in APQ. Otherwise, it's not necessary. Well, is this possible? Now I've got X has A twice, and what would that mean? That members of the population of A play different roles in the relationship with X. That's why I've got A and A2. Okay? How many times do you define a population of A's? What should we be doing? I would hope that it's obvious at this point. Draw a box in your diagram and call it A, period. And that's the representation of all the A's anywhere. And that's what ORM does. Okay? So, I could turn around. Let's do no clustering. I've got populations of X and A and B and P and Q and Y. And I'll draw it like this. And I'm showing you the relationships that are reflected in the table. But notice, I had to have known all of those relationships before I could draw that table, those three tables. The upper diagram is ORM. Object domains are shown only once. There is no distinction between entities and attributes because that's by virtue of a relationship. And all relationships, whether they're going to be inside of a table or between tables, are represented in the same way. I haven't shown any dependencies here. Okay, right now, B is dependent upon X, and P and Q are dependent upon A. That's all I can say here. I can't say that A is dependent upon X or Y. Right? Which do you think is easier to comprehend? Yeah. Grab the mic. This is going to be a meaningful question, right?
Why can't you say that A isn't dependent on X or Y?
Because there could be some A's associated with the Y or in APQ that don't have an X. So we can't say that A, in general, looking at this, we can't say that A is dependent upon X. Okay? And if you turn, and so we make the assumption here that I can't have a B without an X. That's what this structure is showing you. Do you think that would be an important thing to tell the user? If you built this model and say B is dependent upon X? And in the user's world, it may be that it's not. And so you pursue some additional questions with the user. Okay? Under what circumstances do I have some A's that aren't associated with an X? And if they start talking to you about such circumstances, you know what you have to do. You need to have a separate table of A. Okay? Which you already have. That's why A is not dependent upon X. Okay. Well, table think is the problem. Is the relational data model for people or for the system? And I've kind of answered that already, haven't I? We have the relational model for the convenience of the system. Why do we draw data model diagrams? Do I have to build a database if I have a data model?
Wait, so you're talking about the logical level, not the schema level, right, for this question?
Schema isn't dependent upon whether you're talking logical, conceptual, or even physical. Has a definition around somewhere. All the schema means is it's the definition of something. At whatever level, whatever stage you're talking about.
To model the world we're in.
What did you say?
Draw for the user.
Good, thank you. Why do we build data model diagrams? For human communication, understanding, and validation. Because we want the users to come back and say, yeah, that's an accurate description of my world. And only at that point does it make sense for you to go and populate it with real data and start querying it. And start making decisions based upon the information that's in your database, which is a surrogate for reality. Okay? We draw data model diagrams for people. We cast it in a relational model for the machine. And I gave you at the beginning the tableitis description of a serious malady in our discipline. That's because everybody does it this way with tables. So, what's the process of table think? We focus on entity tables. Now notice, I could say we focus on entities, but no, we're only focusing on those entities that other entities play a functional relationship with. Okay? So, in focusing on entity tables, we find the entities, top-down macro view, to find the major entities. Notice I said major entities. And a major entity here is one that's going to need its own table. Or we could view this bottom up. We could say, give me a list of all the pieces of information that may be of interest to you in your world. And then I try to organize them. And what am I doing when I organize it? I'm trying to figure out which goes with which, i.e., where are the relationships? And so for each entity, I design a table and I put the attributes in that entity. The columns are like the attributes, and I have a name and a data type. I can define an attribute or composite of attributes to be the identifier. And there I'm invoking the rules of building identifiers that we talked about earlier. And in the relational model, all of the relationships between entities have to be cast in foreign keys. The relationships that are already in the table, I don't have a problem with, because it's there. It doesn't need a foreign key. A foreign key is only needed when there's a relationship across tables. To jump in and think of putting data into tables means we must have already decided on what are the entities, what are the attributes, what are the identifiers, what are the foreign keys, and what are the characteristics of all the relationships. Then I'm ready to put it into a table. Well, ORM gives you a discipline for looking at all those other things. And guess what? When you're finished specifying all those other things, you just push a button and say generate tables, and there you have your tables. And because the system has all the information it needs to do it accurately, those tables are guaranteed in fifth normal form. So, the relational, we got entities, then to attributes, then we build tables. So we got the table model. In object role modeling, we think of objects, and then we think about relationships and roles in relationships. We build an object model, and then we can generate the tables. Both have the same starting point, entities or objects. Okay. This was my epiphany. When we design a relational database, we are actually modeling all and only the relationships among the things in the user's world. We are only modeling relationships, both within and between entity tables. We can put it in the entity table if it's a functional dependency. We cluster attributes into tables without explicitly defining those intra-entity relationships. Designers make mistakes because they're thinking about tables first. We can only speak of attributes in the context of a relationship. Something is an attribute of something else. We are not modeling all the object domains first. So here's some problems. We've dealt with all of these now. You can read that for yourself. Here's a broader view of what these problems are. We can't capture the conceptual view directly. The human model is responsible for normalization. We have to pick names. Well, of course, you have to pick names otherwise too, but the names of a column have to reflect the role that that thing plays with respect to the entity. Okay. All of these points are a consequence of clustering into tables. They're all a consequence of table think. And all of these problems go away when we use object role modeling. So, what's wrong with ER and relational modeling? This is review. What's wrong with ER modeling? What is it that we do prematurely? Put things into tables. Cluster. Clustering attributes. So, I will show you still a more excellent way, and I have to give my apologies to Paul on this one, but this is the beginning of, or the end of chapter 12 in 1 Corinthians. If I speak of entities and relationships, but I have not ORM, I am a noisy gong and a clanging cymbal, getting all tangled up in anomalies, redundancies, missing semantics, and normalization. If I have all knowledge of ER modeling, but have not ORM, I have nothing.